Hello, welcome back to whatever this is. What is this? Chill maths? Something like that. Hi, anyone who's joining in bang on 2 o'clock. Gonna get some shout outs out of the way because I think I missed some. I missed 3 cubed is 27, Man on a Ladder, M Gam Gam Gam, and Link High Ruled with a 1. I do love it when people have a number in their username. Reminds me of maths. Everyone, how you doing? Hi, Murray in chat. Maths 2222222, and Herbs is here as well. Hello. I have loaded up the thing about dogs again because people saw my desktop background last week, and I couldn't find the code that made it, so I'm going to mess around with stuff again. Using this version of some code that I've got that does dogs chasing each other. Hi, Neutrino. Oh, hello. Yes, we now have RFL as an emote, which is a reference to the natural number game, which we played on stream months ago, goodness me. In the natural number game, RFL is what you type to complete a level in the first few stages. It stands for reflexivity. It's when the thing that you've got matches the thing that you wanted, so we can use it for sort of celebrations if we ever get to the thing that we wanted to do. Which, now that I say it out loud, why did I make this emote? That never happens. We never finish anything. This whole streaming experience is me starting different projects, telling you excitedly what I'm going to try and do, and then failing to get through all the way. That is good. Okay, that's good. Right. Oh, look at there they go. Right, after the excitement of last week's Minecraft extravaganza, this is going to be some dodgy code. Non-zero number. So we didn't quite finish the natural number game because I got to a level that I thought was broken, but probably my ability. I haven't built the Menga Sponge, but I suppose the Menga Sponge goes on forever. Those are the 2 big ones, I think. The 2 big things. And now that I think about it, the natural number game ends with proving Fermat's last theorem, so probably wasn't going to finish that one. We did build that huge Cayley table. Right, okay. This is what I've got. I've got some pretty clumsy MATLAB code that can take some number of, I'm thinking of them as dogs, and have them chase each other. The rule is that each dog is chasing the next one along. The last one is chasing the first one. So inevitably, perhaps they will end up in the same point as they will have chasing each other in a circle. The fun thing for today is I've added a few lines to shuffle what order they're in. So it's still the case that dog 1 is chasing dog 2, dog 2 is chasing dog 3, but they might be in a kind of random shuffled up order. I have this theory that when we did this with lots of dogs on here, look, they managed to sort themselves out, which is something that's very interesting to me as a kind of self-organisation kind of thing. So my theory is that possibly you need enough creatures, but if you have enough creatures, that they maybe do this kind of self-organising. Not pictures, let's have a go. So if I set this to 7, these lines, I had to look up this, but these lines shuffle around which dog is which. We're chucking them into starting positions, and they should just go. So if I just run that, it should throw me 7 points. Let's find out if it can run that while also doing the stream. It is not happy for some reason. Good, I'm going to talk to myself. Oh, and Twitch now says unstable. I've upset everything. Oh, good times. Right, turn that off, turn that up. Why is this unhappy? This is showing me up now. I know my MATLAB code's bad. There we go, that's a bit better. Now I've got excellent connection back again. Sorry if I went weird for a moment. Not promising to be less weird in the future. There we go, so we've got 7 dogs chasing each other, but they've started out of sequence. And then I think the idea is that just because the chasing is in sequence, that they can get into the right order. It's not very clear though, is it? It's not very obvious not very obvious what happens there. There's some sort of sorting. This one really has ended up just behind that one that it was chasing. We're stable. Oh, that's good. Bit of a surprise, to be honest. Got warning lights in here, and I've got warning lights over there. Whoa. Twitch streaming, what's that like? So I think if I zoom into this little square here, I think, yeah, they've kind of sorted themselves out a bit. In this version, I've got them all the same colour, but doing kind of rainbow colours. So I'm trying to guess if they've ended up here, what does that mean? So maybe I don't want that. How can I make this better? I think I do love the rainbows, but I think I want something a bit more like the background, where each dog is a different colour, which is doable. It just means changing the really janky code that I wrote to do the colouring in. Right, so the colour is going to be sampling from time. I just need to make it sample from n instead. That's not too bad. So at the moment we're in here, where it's obviously the best way of doing this. We're just around a factor in here for the number of rainbows, which is going away. 255 is in there. What's the current time divided by the number of time? And we're doing that modular arithmetic, mod 256, and then for some reason adding 1 on the end. Let's clone that, but change it to something like, I want this to be based on the number of the dog rather than the position. So what have we got? It's plotting all, at the moment it's plotting all of the points at the same time. I'm going to need to tell it to plot. This is really clumsy code. It's just plotting lots of dots, recalculating, plotting lots more dots. It looks so dotty. It's not doing anything clever. We'll do a small change first. Small change to try and get the dogs in different colours, and then I think I might spend more time rewriting this to do all the calculation first and then show, because at the moment I think the bottleneck is how fast we can draw stuff, especially with some graphics capability being used on Twitch. Here we go. Right, okay. Short-term aim, get the dogs to be different colours. Long-term aim, plot the whole thing more sensibly. Okay, so this is going to be something like, I can see some code up here that's going for eyes 1 to n, and there's some nonsense on here. Normal MATLAB stuff, isn't it? Oh my goodness. So this is going to do a couple of lines of nonsense to set the colour. So it's getting this from the colour map, which is the rainbow colour map. That's fair enough. We did lots of messing around with colours before, I think, to get the stream colours on the background. I really want to find that code. Where did I save it? And I think I'm going to move this in here. Regret. I'm going to move this in here and just plot each one at a time. And I want this instead of this. So this should still run, but just be really slow because it's now plotting each dog individually. Yeah, using the stream colours is really cool, so I think I want that back. Let's see if I can find that. Oh, I found it. I found it. Go there in a second. So it's still working, it's just super slow. But I have found the version which does n dogs using ODEs. Seems good. What's this? This looks important. Oh yeah, there we go. This is the version from a previous stream. Should be using this version. Right. Finding the code from last time, RFL. Possibly, or maybe people are just excited for the RFL emote. Oh dear. Why is it so slow? Is this doing the stupid thing? This is doing it the stupid way. People who are subscribers are going to get animated version using the automated Twitch animation thing. I've made some straightforward animated versions of our 3 emotes. I'm saying this, I think exactly nobody is a subscriber, but I've also switched on the feature which will let people unlock sub emotes using channel points. We needed something else to do with channel points. There is a feature for animating emotes. I think that'll be fun. I think Neutrino is currently not a subscriber. Not trying to put Neutrino on the spot, but wait, Neutrino has the little star. Neutrino is a 9-month subscriber. I'm confused. Some of my things tell me I have no subscribers. Some of them tell me I do. Good, right. Turns out the approval process for animated emotes, even if you're using the Twitch-based emote modifier thing, still has to go through a slow approval process. Anyway, we will get that sorted. Yeah, sorry Neutrino, you got a little star and everything. I don't understand Twitch. Right, okay, this is the version that we use to make the desktop background kind of thing. Die. Oh dear. But it's really, really slow. And it's doing very nice things, but it's very, very slow. I found this other one. Oh, right, okay. I was trying to find these things before the stream, and now here we are. I don't know what this is supposed to be. Oh my goodness, I hate it so much. This is disastrous. Oh, is this trying to do it as an ODE? Right. So this is some version that can do 3 dogs immediately, but not with cute animation and stuff. Just sort of calculates it. Ah, that's no fun. Okay. So what do I want? I think not that. I think I want to work with this because this is the one we had on stream before, which is nice. Continuity. Random was the most fun. So 20 random dogs. That's what we did for the background. I think I'm going to controversially turn off the thing that redraws it every frame. Maybe if I can find that. Oh, this one's got some interesting break statements on. Yeah, always work on your most recent version of the code. What on earth is this? Oh, this is trying to use the RGB values for the stream colors. Goodness me. We're not using random colors. We're not using... Look at all of that. We spent ages trying to set the RGB stuff to stream colors, but not using that. Using this. So there's a bit in here somewhere that's drawing it. Right. Why is it redrawing? It's doing a plot and it's holding on and it's got all of that and it's setting the background to black. I was expecting there to be a draw now command in there somewhere, but there isn't. So I don't know what's going on. 2 seconds. Is this just doing the naive thing? It's adding on a little bit each time. Finding old code that I didn't put any comments on. Fun times. Welcome to the stream. In this stream, I'm picking up some code from a previous stream. I guess I could watch the previous stream. VOD is on YouTube. And work it out. Yeah, it could be this. Is this drawing it? Let's just move all of this to the end. See if that gets us out of this loop. Let's still try and draw it. It just hasn't put the background on it. I would like it to not redraw every time. And I don't think plot does redraw every time. Maybe it does. Maybe it is this figure one line. Which we don't really need. Because there's only one figure. I think for a while there was a second figure that was showing us some diagnostic stuff. Okay, that's a bit better. Because now it's not showing me the pictures. Which means there's nothing to look at on the stream. So I've successfully made... Oh yeah, there we go. And then after a long wait, I've made a sort of wiggly picture. But you don't get to see it until much later on. Okay, is this an all-timer? Not really sure. Oh, it really doesn't like showing me this. It's really sort of, you can see a little bit, I think, the pausing. There you go, Dog Galaxy kind of thing. So they've managed to get themselves into the correct order. And it's a little bit more obvious, not if I zoom in too far. but it's a little bit more obvious that they've sorted themselves out. Okay, right. Oh, it's so slow. It's so slow. Okay, so we've got very similar shades of blue going on here, but this is the thing that's in the background. I like the way this light blue one. It's got the kind of twists in it a little bit as the thing that it's aiming for. The thing that's aiming for is affected by kind of everything else because it's running towards a dog, and that dog's running towards a dog, and that one's running towards a dog, and as they each move, the kind of target is moving a little bit, partly influenced by its own motion. There's a kind of feedback loop that if the dog shimmies left a bit for any reason, then all the other ones redistribute a little bit. So you get kind of these weird patterns like this with this one going around here. But it seems like they end up in the right order. So if we zoom in again, so this kind of nexus bit in the middle, where they've got into this pattern of looping round and round and round, they're definitely in colour order. I'm saying that because I know what the colour scheme looks like. I appreciate it's not the most convincing thing because the colour scheme is specific to this stream. Anyway, let's try it again because that was fun. Well, fun for some values of fun, right? It's a picture that takes a good minute to load. So it's shuffling at the moment, shuffling the starting positions. Think about where to put them, moving them around, and plotting lots and lots of dots, but we don't get to see them until the end, so as to save my graphics card some work. And hopefully it'll do exactly the same thing again, and then we can make a theory about that. Yeah, that looks exactly the same. Well, no, it looks totally different. What's going on here? So again, you've got ones that follow, and the thing they're following is moving, so they curve and change around. We've got a pair here where, there's kind of three shades, I don't know if you can see those on here, where 1, 2 and 3 of these kind of navy blue, purple coloured spots have done this thing where they're charging almost head on, and one of them turns around to follow, because out of the pair charging towards each other, they don't both care about each other in a symmetric way. One of them is trying to catch up with this one, and the other is chasing something miles over there. So you get one, it's this generic behaviour that I've seen in a few of these. If I zoom in over here, yeah, where you get these kind of sharp turns where essentially they're both chasing the purple and coming in from the top right. One of them really is, and the next one is then chasing that one. So you get these kind of sharp turns as the thing kind of misses and keeps going. That's got a name. Not very convincing in here, is it? Don't love that. I've zoomed in so far that it's got unconvincing. There's some fine detail that's not being resolved here. But essentially, if you zoom in enough, that purple dog hardly cares. Its target is somewhere miles off bottom left of the screen. So it's kind of moving in almost a straight line. And this one coming in from the left here, dot, 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 does this really quick whip round, turn round. That's got a name. I think that, let's see if I can look up the name properly. I have not spelled the name right, so we're going to have a second attempt. No. Let's go for a two-step way of looking at the name, because I've forgotten the name of that shape. Oh, it's nowhere near. Hairpin turn, yeah, that's the one I want. Right, I got some of the consonants wrong. I think it reminds me of this radiotrome shape, which is the classic dog chasing a hare. So this has got its own Wikipedia page. It was described in 1732, says Wikipedia, for this kind of turn from the dog chasing, in this case it's called a hare, and the hare has different dynamics in this simple example. The hare's just moving in a straight line, and the dog does this kind of turn like this to catch up. Or I suppose a turn because it's chasing where the hare literally is, not where it's going to be. and it ends up behind. So I suppose what I'm really seeing is like these red dots, or an approximation of that. But yeah, turn around. Ooh, if you put this in Desmos, let's have a look. I've had a go at playing this Desmos as well, I think, at some point. Oh my goodness. Yeah, that's this in Desmos. Because Desmos can do iteration. How does it run? How do I reset? Yeah, let's reset. Okay. Thank you, Maths222 in chat, for putting this in Desmos, so that we can all play along at home. If you'd like to play along at home, there is a link in Desmos chat. It's pretty cool. So is this setting to... I don't know what you're doing here. Oh, random start points. Random start points. Ah, I remember this. You put something on the Discord about how you're looking at how that shape changes area over time. And I'm interested in how the points are now in order, so it's a convex shape. I didn't read enough of the thing you put on Discord to work out if it's obvious that it becomes so it's sort of becoming more of a regular polygon. Oh, I like this a lot. Regularizing. Yesterday I tried to start a calculation to do a kind of stability analysis. What we're seeing here, I think, is that after a while, if it's close to being a regular shape, it's stabilizing. I'm just going to use this now, I think. Oh, one person running this at home. Run this at your own risk, I guess. So this is sort of sorting out, but then followed by that's not a very regular polygon. My prediction is that what happens next is it gets more regular. Ooh. My prediction was not that it would do that, whatever that was. Okay, so if I pause it, weird stuff. But look, there we go. Dog Galaxy kind of stabilizing in to become more of a regular polygon, and then collapsing very slowly on the way in. If you have lots of dogs, you can do this kind of theoretical prediction for how that collapse works. The colours are really cool. I don't know how you've done that at all. Oh, my Desmos is also not happy. Are you redrawing the points? Oh no. Oh no. Wait, I've got better at this. Be gone, we already have the best viewers. Right, okay, my Desmos is also now unhappy. So I'm going to close this. I'm going to leave. Might open another copy. Thanks for that. That was really exciting. It does the same thing as my MATLAB code, doesn't it? But in Desmos. How am I going to play this? So I could have a terrible attempt at doing the stability analysis. I could do that. Might be good. Oh, if I want to look at the code. If I want to look at the code, I'm supposed to use fewer points. Let's look at that. Oh, I've reset it with fewer points. Don't like it. Then I think I'll have a go at the stability analysis, because I think that's the thing that I can do, or at least fail to do in a live stream sort of way. See, I'm just not going to understand this, am I? No. And then that number 0. That's drawing a polygon. And then what on earth is this? I suppose I don't really know what this is doing. Those are just color randomizers. What? Oh, are they supposed to be different colors from each other? But there's some neon green in there as well. Oops. Yeah, okay, I get it. They're supposed to be different colours from each other. I didn't notice that on the first point of asking, because there's some sort of weird glitchy ones. Some of them end up with the same. Ah, the neon part is supposed to be where they currently are. Yeah, okay. So is it redrawing? Oh, this one's not happy, is it? Part of my theory is that it doesn't stabilise if you don't have enough dogs. That with 4 or 5, I think it doesn't form a regular shape. I think it can be still wonky on the way in with 4 or 5, but that's an experimental result from looking at stuff like this. That's not something that I have any maths reason to believe. Maybe if I do some stability analysis. So is this one going to sort itself out into regular pentagon? Actually, I think it's what it might. I think it's going for it. It's going to make a bid for a regular pentagon. Go. Quite like having this in Desmos rather than MATLAB, thank you, because I can zoom in live. Although it's really not very happy with me. Let's pause that. I think that was going to become a regular pentagon. Right, good, okay. Yes. Who am I? What am I doing? Just doing random stuff in Desmos. Seems like a good day. Okay, let's try and do some maths on this problem. Seems like a me sort of thing to say. Hello, good to see you. How are you doing? Oh, it's Last Jammer. Sorry. Hi, Last Jammer. I knew it was Last Jammer by the dinosaurs. Right, okay. What is this? Why is it happy? There we go. Okay, so if we've got some points that are chasing each other like this, then I think in 2D I want to use something like complex numbers to explain where they are. And then track how those complex numbers change over time. But I've done this a few different times in a few different ways. I'm never really sure that I'm using the best method. Complex numbers are cool. Everyone likes complex numbers. Let's give that a try. So the basic solution that I want to start with is to have all of the points on a regular shape and to explore how they spiral inwards over time, because that's what we've seen happening if it's a regular polygon. And then if we can do this, I want to think about small perturbations to say, oh, if the points are on some sort of spread out shape, that might tend to settle in towards a regular polygon. There's just something going on there where they tend to cut corners in a way. Bless them. But the ones over here, no, wait. So what would the mechanism be? Something like the ones over here are going inwards more than the ones over here. So there's a kind of squashing effect on that shape. And it's quite hard to talk about the shape when you've only got finite points. I guess maybe I'm joining the dots, or I'm imagining some sort of smooth shape that they're on the boundary of. See how they're going through. Ooh, maths do in chat says don't do absolute values. 3 days of pain. If you've been doing this for 3 days. Well, get some holiday project, I guess. Right, let's do the regular case first, and then think about perturbations in that order, possibly with some sort of break. My tiny little box office is really warm today. It's really warm. Right, okay, let's go. Okay, so we're going to let the positions be something like this, where Rn depends on time and theta n depends on time, and these are where they are. Then the motion is given by something like the rate of change of this position. It runs towards the next one, so its direction is relative to, this is xn, it's looking at xn plus 1 and it works out that direction, but it has a speed of 1, so it only moves a certain distance in that direction in unit time. So I want the direction of that kind of displacement vector or complex number, but none of the magnitude. I choose the magnitude. The magnitude is 1. Unit vector in that direction. I am talking vectors, but I've written complex numbers. I'm just going to try and get away with that. So we're going to suppose that theta n is, so for a kind of regular shape, for a regular polygon, we're going to suppose that theta n is, and then I think I want to do something like this. I need a large n points or something. I want a regular n-gon, big N. But I suppose it can't quite be that. I don't want the I there. So if you like fractions of 2 pi. But I don't quite want that because I want them to be able to spin. So I'm going to add a kind of, I kind of want to just call it a theta. I'll add phi for some sort of angle, phi of t, which is some sort of rotation for all points. So they're going to rotate together for this regular polygon. Mumble, by rotational symmetry, they're all in the same situation, so they're going to rotate at the same rate as each other in this regular case. That's the sort of thing that we might put some perturbations on later on. Hello in chat, Samuel Singleton. Nice to see you. First time chat. You've joined just as we do some maths. We're trying to explain some behaviour that we've seen in, it's not a great diagram, some behaviour that we've seen in patterns of dogs chasing each other. There's this kind of stabilising effect, which I'd like to try and turn into maths, so that even if they start in random positions like this, different colours for different dogs, each one chasing the kind of next one round, the kind of closest colour. The colours mean what order they're chasing each other in, not their starting positions. Thanks for the follow. The observation is that they end up spiralling this kind of dog galaxy thing, where they sort themselves out, and maybe with some terms and conditions on the number of dogs, they are in the right order, and that seems to be getting more and more regular as the shape goes in. Here it's kind of an ellipse. Prediction is that if we kept running this, maybe the ellipse would get more circular. So we're trying to understand today regular polygon behaviour, which should be easy, and hopefully start to think about maybe ellipsoid perturbations to change that shape to see how they can stabilise inwards. Okay. Right, the regular polygon case really is the sort of puzzle that I should be able to do, because I can do it. For some reason I'm doing it with vectors and complex numbers, when perhaps I should just be writing down circular motion equations or something, but where's the fun in that? Okay, so and then Rn. So I've said what's going with thetas. They're kind of equally spaced on a regular polygon, but with some rotation rate. The polygon's rotating. It's just what we've observed. And Rn, I'm going to say, what if that's the same for all? Same for all. That they move inwards together. And both these things will change a little bit depending on n, small n, in the case where we have an ellipse or something. Okay, so xn dot on the left, we know that xn is Rn e to the I theta n, so I should put in something like this. Rn I theta n dots by theta n by product rule, chain rule stuff. Good times. And on the right, we've got something like Rn, which is the same for both of them. Rn e to the I theta n plus 1 minus e to the I theta n divided by the modulus of that thing. E to the I theta n plus 1 minus e to the I theta n. Absolute value. Yeah, they follow each other in a loop. What's Zeno's mice problem? Oh, is that the name of the problem? That's what we're doing, I think. Yeah, it's the mice problem. We're doing the mice problem. There is a Wikipedia page for this, which you might enjoy, maybe. Observation, this e to the I 2 pi n over big N has modulus 1 and it appears all over the place. So you can pull some things apart. Thank you for the follow, dears. EERZA1. Thank you for the follow. Right, here we go. So, e to the I theta n appears almost everywhere. I'm going to divide both sides. I'm also taking the opportunity to tidy up that term. To get something like this. And in here, what have I got? This will become e to the I, and then there's some rotation that's the same. The phi is on both sides, but that's all right. E to the I pi is the same on both of these. It has modulus 1. So actually loads of stuff cancels. So just leave this much. Divided by its modulus. I'm pulling out factors like e to the I 2 pi n over big N, which I've divided by sides, and e to the 2 pi I n over big N has modulus 1 anyway. So it appearing in both of these means I can pull out the factor, and its absolute value is 1. And what are we doing? Doing some dividing? Yeah, this is just something that depends on large N now. This has got a real and an imaginary part. So we can piece that together. And yeah, I think I'm happy. I've got some real part of this side that tells me about R dot, and I've got some imaginary part of this side which tells me about that stuff. I think R is real. So this cancels, I think. Yes, good, okay. Okay, bit nervous, but I think we're getting there. I think I've invented, if you've done circular motion, you've seen these things on the left. Radial velocity, angular velocity, and on the right I've got the components of the velocity of each dog. Yeah, if you like components and you like mechanics questions like that, then you might have drawn some geometry picture with the relative positions of these things. You might have told me that there's some angles going on and that you can just chase things. But I have chosen to do everything with complex numbers instead. This could be much worse. This is the circular case, or the regular polygon case. And it could be much worse. I'm just going to write this out. And there's an I sign. Okay, this is going to be a little bit bad going into components. But I've seen worse. And this is divided by the modulus. Do I want to write out the modulus? A little bit. Just because it's a number, it's just a number. It can't scare me. I'm not scared of the number. A bit scared of the number. Okay. Using the fact that cos squared plus sine squared is 1, 1 squared is 1, welcome to the stream. 1 times 1 is 1. Thank you for joining my Twitch stream. Minus 2 times cos. There we go. Okay. Don't know if I like that. Might get rid of it in a second. Might send it back to what it was. Okay, good. So this gives us the rate of change r over time. I feel like I've missed a factor of r or something, because that's going to be a constant rate. Is that what I want? Yes, that's what I want. It's not an exponential decay sort of situation. They just collapse down in finite time. So, right, okay. So this is going to be r is equal to, if anybody asks you, it is, well, this number time. Is that negative? That looks negative, doesn't it? It's cosine of something minus 1. Looks quite negative. So we're going to go for some sort of starting radius minus time, cos 2 pi n minus 1 over square root 2 minus 2 cos 2 pi n. Actually, now I regret writing that out because it's slightly more writing, possibly. Okay, and then that appears in this differential equation, where we have something about r theta dots. Right, and so the theta dot equation is going to have a 1 over something like 1 over t. So theta is going to behave like log t. Which is the infinite amount of spiraling sort of idea. I'm going to call this number alpha or something. So then you have r0 minus alpha t times theta dot is sine 2 pi over n. Does that simplify? It looks like it might simplify. Oh yeah, it does simplify, doesn't it? Thank you. Because I can use cos t theta or something. Wait, no, just because a factor of root 2. Am I being silly? Yeah, it's just a factor of, there's a 1 minus cos upstairs and downstairs. Sure, so this is something like 1 minus cos. It's big square root, and there's a root 2 down here. Or something. I don't know if I want plus or minus anymore. I've got scared about square roots. I think my plus. Yeah, why did you write minus sign here? Okay. Why did I write minus here? Because I'm wrong. I was too busy thinking about negative numbers. Negative numbers. Okay, not too bad. Theta dot is something like this. And again, maybe this is going to simplify. So when you integrate this, you get something like this number out the front, and there's a log, and I need to divide by negative alpha or something. And when you put in 0, I don't know, there's lots of ways to do this, but I could divide by r0. So fixing the constant and putting a theta naught at the front. It's probably the cleanest way to apply some sort of initial condition. So if you start from theta naught, then at time 0, you have r naught over r naught, which is log 1. Log 1 is 0. Yeah. Still simplifies. You are going to use small double angles as well. Yeah, you could. Because that's cos t theta is that cos 2 pi over n is 2 times cos squared pi over n minus 1. So 1 minus that. Big pause. What have I done? Big pause. Did I want the sine squared version? 1 minus 2 sine squared pi over n. Yeah, I could do that because then it's 1 minus this, which gives me the root 2 back again. So that's nice. Yeah, use both ideas. Use both ideas. This time I think I do want a minus sign, so that because r is decreasing over time. Yeah, it's pretty good. Sine pi over n. Yeah, no, I buy it. Oh, so if alpha is just sine pi over n, then down here somewhere I have opinions about simplifying this one as well. Or maybe alpha is minus sine pi over n. I've got a bit confused in my double angle formula stuff. Hello, if you've just joined, we're doing double angle identities to try and simplify a result for, oh goodness me, ages ago there were dogs chasing each other in a circle. It was great. Now there's just trigonometry everywhere. Okay, we've got a solution in some form. Maybe with min with a minus sign. In some form, we've got a solution for regular polygon. The plan, I think, is to do a perturbation to this. It was great, and now there's just all this sine. I'm getting suggestions in chat to use things like double angle formulae, but I do know. Okay, right. What am I doing? Okay, so the hard bit is setting this up. So if I go way back up here to the kind of regular polygon stuff, weird that we didn't solve for phi. Maybe I meant phi all the way through. Yeah, this is probably a phi dot. I can fix it. Yeah, it's just a terrible choice of notation up here. And then this theta means, yeah, good, okay. So, I think so changing the positions a little bit changes all the stuff on the right hand side. Quite a messy way. I mean, each xn changes position a little bit. But also, that would say the real and imaginary parts of that will contribute to a kind of slightly different change in Rn dot and a slightly different theta n dot. But these things on the left with n's in will be slightly different if all the positions are slightly off from a regular polygon. And tracking that to a kind of first approximation is going to be the hard bit. I'm trying to work out how to write the positions down. Do I want to do something like call this solution at the end x naught or x hat or something and add perturbations to that? I think I should do it like that. But the RNs don't add. RNs don't add. Is that a problem? So you've got a choice, right? You can add a perturbation or you can perturb Rn and theta n separately. To say, when you look at a dog that's slightly out of position from a regular pentagon, you could say, aha, that's got a little bit of displacement, Cartesian, x and y. Or you could say, aha, polar coordinates, r and theta, this dog's position is a little bit different. There's no kind of right answer, it's just, if I pick the wrong one, the algebra might be much worse. So, you know, the maths itself doesn't really care how bad my algebra is. Things can be possible, but in poor choice of coordinates. I've started polar, maybe I should stay polar. Yeah, maybe I should stay polar. That sounds fun. Can't remember the last time I did one of these. So I'm going to do a series. Is this really what I'm going to do? I've got positions, and I've got radius positions that depend on n, depend on time, and are now also going to depend on epsilon, some small parameter, sort of, maybe. So let's go perturbation. So perturbation is where you change things just a little bit, normally by using the letter epsilon to represent a small change. Okay. If I make it to 3 o'clock, I can go and have a cup of tea and think about what I'm doing, because I think I'm going to get stuck very, very quickly. If I make it to 216 followers, then I hit this, and then I can get back in Minecraft or something instead of the other way out. Just to do a calculation so engaging that it gains me 11 followers. Implausible at best. Right, okay. Let's go for it. So we're going to write Rn hat theta n hat for the regular polygon solution. We're doing a perturbation about an evolving state, which is not really good. So in particular, something I'm worried about is that one mode of the perturbation is just get there faster, where there's a mode of shuffling the positions of all the dogs, which just moves them forwards in time to where they were about to be, which then won't... Feels like that might be semi-stable or something. Oh, anyway, it's a the time shift is a symmetry that we're going to include here, I think, inevitably, however I set it up. Anyway, a lot of it is in the setup. Now, let Rn be, so these depend on n. This one doesn't depend on n. This one does, but only in a rubbish way. That this was just that plus rotations for a kind of regular pentagon. But the only thing really going on was this variable theta. Okay, so we have our regular polygon solution, and it is evolving with time, but I'm not going to let that scare me. Because now I think it's time to think about this kind of small epsilon kind of change, which could depend on n and will depend on time. So hopefully, if we do something like this, to change each position, and do theta as well, but to change each position from the regular pentagon solution by a little bit, where this new variable represents the kind of shape of how we're moving each one, capital R, for a little bit of change in some shape. The shape might depend on n. The displacement changes might be larger at the ends of like an ellipse kind of shape, like we saw in this diagram. The change of positions, we might perturb them different amounts for different numbers, but that's going to evolve over time. And I hope, if hypothetically we get down to a result, then I hope that this decays over time. We're going to try and do some linearization and try and force this to obey a simple set of differential equations, maybe. And we win if this thing is going to 0, because then it says, aha, you perturbed it away from the regular polygon and you got some leftover bits, which are decaying over time, so it's getting more like the regular polygon solution. And this bit I have, okay, so I'm going to do the same thing with the angles, because I think inevitably they are out of position in angular displacement as well, or that they won't, even if they happen to be in the right angular displacements right now, they might be getting out of position. I'm not sure how much I care about this. I think if I can solve this because we're at some particular moment, the angles are right, but the displacements are wrong, to see what's going on immediately in that situation, that's quite convincing. Technically, I should look at all possible perturbations, but I'm worried that some of them are stupid. Okay, I suppose I have to call this capital theta, don't I? That's an n, that one depends on n. I suppose I have to call that capital theta. I have a regret. The regret is my choice of letters. Doesn't look too bad. Doesn't look too bad at all. So what have we got? We've got our differential equation, which is this thing over here. There it is in all its glory. This is the differential equation after we switch to using r and theta, complex numbers, polar form of positions in 2D. It's after we realised that things cancel, but it's before we started using the fact that Rn for a regular polygon has a particular nice form where all the r's are kind of the same. So I'm going to try and sub this in, I think, to say that you have, I've got hats and dots going on. I'm going to do both, I think. It's not advisable, but you know, sometimes you got to do it. Okay, so we're going to have r hat dot. I have two regrets. Plus epsilon Rn dot e to the I theta n, where I've got an expression for that. Plus, and then this one's going to be Rn I, and then theta n dot is pretty interesting because that's theta dot plus epsilon theta n dot, because this theta n hat, lowercase theta, was the original pentagon, original polygon angle stuff, which has some sort of normal displacements which don't change over time, and a time dependent part which was just called theta. So I'm pleased to see some familiar terms appearing in here over on this side. On the right hand side, everything's going to be a mess, isn't it? Yeah, those r's those r's are not really the same. So I'm already not sure. Yeah, I'd already done some simplifying. Okay, so I like the left hand side of this. So realizing that I like this bit, but I'd already started simplifying over here. So I think I need to get back up here for my right hand side, because these r's are going to be slightly different. I'm only at the epsilon level. So this is position xn plus 1. I'm going to write e to the I theta n and think about that in a second. And this is going to be epsilon Rn e to the I theta n. That's theta n plus 1. Ooh. R hat dot squiggle if we do a Laplace transform, yeah. Divided by the modulus of that. Okay, looks like a mess. Almost 3 o'clock. What am I doing? Lots of things. Doing lots of things. For example, this Rn over here, if I just want the order epsilon stuff on both sides, what's all of that? I'm not giving it a name. If I just want the order epsilon things, then I can neglect epsilon squared terms, and there's one hiding in here. So the thing that's stopping me from copying out the definition of Rn is that it involves loads of terms, but there's some epsilon squared things. So on the left-hand side, the kind of order epsilon term is Rn dot e to the I theta n. Oh, do I want to do something with that as well? Order epsilon. Yeah, I've got to be careful. I've got to be careful. I've remembered that there's some epsilons up here as well, which could matter. They could matter, couldn't they? Small bits of rotation that are kind of multiplying everything. Yeah, gotta write them down. Gotta write them down. Where's the tea gone? The tea's gone. Tea's not supposed to be gone. Let me switch it back on. I did fiddle with it. I fiddled with it, but emergency. I can't have a tea break unless I switch it back on. How did this work? Where was I when I did this? Community. This is the most important part of our community, is the idea of having a tea break at 3 o'clock, where we also sometimes remember to run ad breaks. It's what we've got. Power-ups and channel points. If anyone's got a suggestion, there's this setting to like rename the channel points to something else, but I couldn't think of anything that wasn't really cringe. So yeah, no, let me know. Where's the tea gone? I did switch it off. Okay, I don't know if you have to refresh the page or something. You do not have to refresh the page. That was amazing. That was seconds. Right, thank you for redeeming a tea break. That was so fast. Right. You knew it was a race, right? You knew Mary wanted to hit that button as well. Right, cool. We're going to take a quick break because it's 3 o'clock. It's a reminder that if you've been looking at a Twitch stream for an hour, then look at something that's not a screen for a second. We're going to run an ad break because this Twitch stream is permanently supposed to be supporting charity, and it only supports charity effectively if it raises any money. The charity doesn't care very much about the actual stream as far as, well, no, maybe they do. I'm talking nonsense. Everyone cares about the stream. The stream's great. Right. Right. Okay. See you in a minute and a half. I'm going to grab another glass of water. Everyone, do your best. Yes. Think we're back. Are we back? Might be back. I'll wait for people in chat to let me know. Oh, let me guess. Herb's been advertised some sort of sports car or maybe a fancy watch. Something really top end. And nobody else has seen the same advert. Yeah, it is almost A-level results day. Good luck to everyone waiting for A-level results. I think it's going to be okay. No ads. Hope you enjoyed a minute and a half of peace and quiet. Okay. If you've already bought them, that's how it works. They leave you alone once you've actually bought the things. It should be an option, shouldn't it, to opt out of an advert by saying, "I already own this. I promise. Just bought it. Here's my receipt. You can stop advertising it to me." And that'd be good for the advertisers too, of course, because they don't want to advertise you something that you already have. I don't know. Not okay, but weak hope. Good. And Maths 2 suggested that we rename channel points that which has no part to reference Euclid's elements, which is quite niche. It's good. Is it the best we can do? On the theme of something with points. Anyway, okay. One to think about. Please don't spend any of your brain power thinking about what to rename channel points. Right. Okay, before the break, we were about to do some sort of expansion to find the order epsilon terms of a pretty horrible looking differential equation. I'm quite scared of the right hand side where there are all manner of things. But I've cheered up a little bit because I've realised that I can divide both sides by e to the I theta n, which is in here, I promise. And then move most of my problems to one specific point, which I think I will do now. It's a cool name, but we need to shorten it, don't we? I like the idea that the points on this channel are points of space or zero-dimensional things. Anyway, okay, I'm going to divide by e to the I theta n on both sides. I can see it in so many places. Look, here and here and here. That's the thing about exponentials. You differentiate them, you still got exponentials, so then you can kind of mop up all the exponentials. What am I talking about? I'm just saying anything to avoid writing down more maths. Sometimes I just need a little bit of psyching up. There we go. So this thing is going to be equal to, and now I've got a very interesting term over here, which is the effect of n plus 1, but it's now all moved over here to just be this difference up here. And it's not even the difference, this is good, it's not even the difference between angles really. I guess it is. There's a bit of the fact that they're just in different places because they're at different points on a regular polygon, more or less. That's going to be the main part of the effects there. There's going to be an order epsilon correction though, which I look forward to calculating live on stream. Bad news, I now probably have to write out what I'm taking the modulus of. Oh no, I multiplied by something with modulus 1. I'm okay, I can still write mod that, even though it's a different this or that this time. Right. What is Herb doing? I saw the word quote book and I got worried, but I'll just let that happen. Cloudbot is supposed to do quotes as well, but I don't know how to run it. So I think it's the sort of thing, if you have a team of moderators, they can also moderate your quote book for you, which we're not there. Oh dear. What am I doing? Some of these things we've seen before. This is the beauty of doing this kind of expansion. Like this and this we've seen before. Well, the first term of that. This Rn has got a couple of terms in it. But the first one we've seen before as being the motion for a regular shape. I'm going to close some things just to try and make my computer run better because I am getting Twitch notifications. We're going to say goodbye to the thing that draws dog pictures just quickly. That, I think, helped a lot. Also because my computer is putting out loads of heat and it's a warm day. I am going to boil. Right. Oh, it's general quote book. I'm not worried. Good. Almost said what are we doing a third time. I think I'm ready to calculate this now, which is the kind of order epsilon stuff, the amount that this small perturbation, the shape change, the thing that I really care about. But it's also involved in here are loads of extra things that I don't really care about. That's life, I suppose. And in here somewhere, that Rn contains Where's Rn? Scroll up. R hat plus an epsilon sort of thing. Oh, so there's an R hat I epsilon, and then all the terms, trying to gather together all the terms that have epsilons in. So not both of these. I don't mean both of these. Wrong. I want this. And then in this one, I want to imagine what happens when I'm imagining multiplying out, which I'm doing quite clumsily. This Rn, small rn, which contains an R hat, which could be multiplied by this epsilon term, and it also contains an epsilon large n like this, which could be multiplied by this term for some sort of epsilon sized effect. This hydrate's been switched off as well. Power ups and channel points, power ups and channel points. Oh, it's just gone. Quick. Quick. I can't remember what it cost. Oh, why if I set it to 1021? That's a typo. There we go. Okay, there should be a hydrate option now as well. Sorry, I was fiddling with stuff and turned things on and off. Request for 3D version. Yeah, so as soon as I wrote down the complex numbers, I thought, chat loves complex numbers, so I've ticked off one thing. But the other thing that chat loves is higher dimensions. Chat, at various points, chat has been very, very keen on using complex numbers for everything and moving to higher dimensions. And those things don't work well together at all. So if I do one of them, I'm quite susceptible to the attack of, well, why not both? And both is terrible. People invented really weird number systems for that, right? That's why we have quaternions. Did it used to be 500? 2 channel points. I put it as 1024. I think it was powers of 2. Was it 512 before? Well, whatever. Remember the hydrate either way. Whatever power of 2 you see on Twitch, remember to drink water. We developed a weird parasocial sort of power of 2 based hydration strategy, which has some downsides. Okay. Have I got any tricks? Have I got any tricks for doing this divided by its absolute value? I think I don't, which is a shame. That e to the I theta n's gone because I divided both sides by e to the I theta n. You do love generalizations. Everyone loves generalizations. On the right hand side, we've got things like that I want to explore, like this small change in angle, which we have some expressions for this because, well, we know that each of these things is some sort of theta hat, but those ones, the original regular pentagon things, just differed by 2 pi n over capital N. And there's also some difference here with epsilons in it to do with the kind of new difference in these perturbed angles, which is so laws of this e to the I 2 pi n over n, the thing it was before, but multiplied by e to the very small thing. So then I guess I want to use the fact that let's do it properly. This thing, so this is 1 plus epsilon capital theta. I regret so many of my notation choices here. This plus big O epsilon squared. So leftover terms, there's more stuff coming from this expansion of this exponential, but it's like of size epsilon squared. So there's a notation which, broadly speaking, everybody hates, where you write down plus some stuff to do with epsilon squared plus big O epsilon squared. It's big O notation from complexity, from computer science. People do not really like using it in equations. The difference is that some people are willing to do it, and some people don't like it and are unwilling to write it down as well. Hello, Charlie. How you doing? You join us for some, oh my goodness, trigonometry, complex numbers. We've got things moving around. We've got differential equations. Everything is going on all at once in every direction. Because I've returned to the dog chasing problem to try and do a calculation, and it's not going very well. You've been doing step support program. How's the step support program going? Is it going okay? I did a step thing this week. Went and helped some people with step problems. It was quite good. It turns out I can just about do step problems if I practice in advance. And then as extension questions, on this summer school they had some BMO Olympiad questions, and I cannot do Olympiad problems. So I found my level, right? I can do step problems if I revise A-level maths a bit and practice, but I cannot do Olympiad problems. Yeah, break's good for you, although using your break to look at my page of epsilons and calculations. Is it return of the step live stream? You know, I thought about doing more step live stream stuff. Maybe 3:30. We'll throw another 10 minutes of this. Charlie's not keen. Oh yeah, Charlie's on a break. It's very divisive. Yeah, I guess at some point in my life I've been better at doing Olympiad problems when I was more into it, and I sort of thought getting older and wiser I'd maybe be able to see what was going on, but no, it's just can't tell what's going on. Yeah, A-levels. I don't know how much A-levels cost if you're a private candidate. I probably should know that sort of thing. I imagine it varies quite a lot. I know that ones where you have to do science practicals, that's an expense. Oh, yeah. That's an expense that wow, it's just quite hard to do that as a private candidate. I think you have to, like, if you need to do stuff with chemicals and for your chemistry A-level or whatever, then you kind of have to find someone to do that, I think. So it's just very tricky. That is free. Right. What am I doing? I've got things that look like epsilons. I was just going to pull out all of them. The thing is that there's two sorts of things going on here. There are two sorts of things going on here. We've got things like this. And we've got things like order epsilon things. And then we've got a different sort of order epsilon things, which involve the R hat and the kind of epsilon shaped stuff in here, which still has an angle in it. I wasn't really expecting that. It still has this kind of regular polygon angle involved. And then we subtract off some stuff. Yeah, perfectly sensible expression. Good Twitch content. This is what Twitch wanted, I'm sure. So maybe Is this going somewhere? This has got epsilon in it. Doesn't I? We've got 3 sorts of epsilon term in here. That doesn't seem right. But it is. 3 sorts of epsilon term. Yeah. These two kind of go together. They're an expression about how the position is different, and these two is something to do with the change in thetas. Yeah, it's got 4 terms if you imagine this as 2. Change in theta, change in r. Relatively. Both of those things having an effect. Yeah, I'd expect Rn changing, theta n changing, Rn plus 1 changing, and theta n plus 1 changing all to show up in this equation, and they have. I'm a bit nervous because, my goodness, that's a lot of terms. And I haven't even dealt with the fact that there's more epsilons down here. So for this expansion to work, I kind of need a sensible, we need an expression for a plus, kind of, if I've got 2 complex numbers, a large one and a small one, divided by the modulus, because there's lots of sources of that epsilon term. So I need a good way to calculate that. In terms of, I would like to do an expansion in epsilon to order epsilon. So kind of first order term is like, there's this going on, which is the complex number we had before for the regular polygon stuff, but then there's order epsilon things, and not just this. There's also an order epsilon thing that comes from the fact that this thing is not quite, the denominator of the fraction is changing as well. But I can allow for that, I think. So that would be an effect from this denominator changing. What's the game plan here? So we do this expansion. This seems like the sort of calculation I can do in the next 5 minutes. But it's not going to be a very triumphant finish. I don't think we get to use the RFL emote, because even then we've still got a differential equation, right? We've still got something where the real and imaginary parts of this, when all the dust settles, are going to be complicated expressions in terms of Rn plus 1, theta n, and theta n plus 1. So it's not going to be very pleasant, and I feel like I might also need to do some analysis. The analysis on that system of differential equations is also going to be horrible. Because, oh gosh, I would need to say something like, for any shape, for any perturbation, like, I don't know, do some sort of Fourier modes, discrete Fourier modes on the Rn's and theta n's. For any shape deformation, solve for the evolution of the parameters in that. So there was a shape parameter for the R perturbation, for the theta perturbation. I want to see the amplitudes of the R perturbation go to 0. That's still a coupled ODE, even once I've put in a Fourier mode. So I'm going to do this to get down to an order epsilon expression. One of the dogs on. Oh, the dogs are now here. They finally found me. They've been running straight towards me at constant speed for the entire stream. And I've been sitting still. They're getting here. Oh my goodness, oh no. Right, I'm going to get an expression for this. I'll claim, oh, and that gives you an ODE. The ODE is actually extremely difficult and contains 2n variables in a coupled state, and it's not obvious how you would then analyse that to actually show that perturbations go to 0. Possibly I would pick my favourite perturbation and pretend that that's enough. It's not. So we're going to do an expansion on this, say that gives us different equations, and say further research required. That's the plan for the next little bit of the stream. And then I want to talk about the mice problem, the ant problem, because I think it's more fun. Okay, I'm going to finish doing essentially my homework, say further research required, and then do the ant problem with you all instead. I like the ant problem. Right, okay. So the hard bit here is this, which means something like 1 over a plus epsilon b. This mod sign thing means that you multiply by the complex conjugate and take the square root. And that's really unpleasant because, well, there's just loads of stuff going on in here, including some epsilon squared things. So we're going to pull those out to say this is 1 over mod a, and then square root of 1 plus epsilon b over a, 1 plus epsilon b bar over a bar, which to order epsilon. Channel points to do a step question. Good vote. No, we've had mixed experiences with voting, haven't we? I think we voted for the natural number game, and then I found out that you could. The thing we were voting on was whether or not I would be able to make progress in the natural number game, and then I found out the people who voted against that, I'd accidentally set them up to be, you know, they did not have my best interests at heart from that moment on. I think I want something like this. In all its glory, so this is like, there's like order epsilon squared stuff all over the place, and calculating those terms would be horrible. I like glass chains. Yeah, I know a bit of linear algebra, and the people in chat know quite a lot of linear algebra. Do you want to pop, if you've got a linear algebra question, you could put it in chat, and then even if I don't see it, maybe someone else in chat might know what you're talking about. Welcome to the math stream. Chill maths. Just doing some different equations at the moment. Is there a way to set up so it takes all of your channel points? No, and I don't know how many channel points you've got. There are some problems. Do a vote thing, all or nothing. Oh, should be a double or nothing option, right? Should be able to do trivia questions where people double or nothing their channel points. If you've just joined, channel points don't mean anything, except that. That's what channel points do. Channel points can remind us to hydrate. It's like Tamagotchi. So hydrate applies to everyone. When someone redeems that, it's a reminder that all of us to just drink some water or something. It's a warm day. I mentioned the set of solutions for a system of linear equations. Yeah, I remember that a little bit. I'm going to let someone else do that. Chat, see if you can help. I'm going to get to it in a second. Okay, Glass Chains has asked us about dimensional set of solutions for a system of linear equations. We're going to have a go at that in a second. I need to multiply this out. So this is 1 over mod a minus a half. And there's an epsilon term. There's all of this junk. And I've got to the point where I say, aha, this gives us the order epsilon correction due to the fact that we are dividing by a plus epsilon b. So then it's fine. You just take this, you multiply all of the stuff upstairs by this, and take the order epsilon terms, and that gives you a system of differential equations, which you then solve. Sounds terrible. Right, okay. Dimension of the set of solutions for a system of linear equations. Let's do that. Sounds fun. Okay, I am drawing a line under dog calculation. I'm going to write to be continued, but we kind of all know that that's a lie, so I'm going to put a question mark. This calculation has got a bit out of hand for a stream. feel like maybe very keen summer project, maybe. Give someone a summer project to just do this, and they'll also follow through and do the Fourier transform. They would need first year Fourier series. They would need maybe they could do this. Do some computations on the differential equations as well. It'd be good. It'd be good for them. Find a very keen summer student to do it. Right. Yeah, this is going to involve determinants, I think. We're going to make a little example. High class chains. Of a linear equation. No, they've got a system of linear equations or something. So they've got something like some system of equations that says something like this. And they'd like to know the dimension of the solution space. Because when you've got multiple equations like this, it might be the case that you just get a unique point as your solution, or you might get a whole line of solutions, or you might get a plane of solutions. The dimension there is essentially how many linearly independent vectors you've got that satisfy these equations. It might be none. If the determinant is 0 on the left, then the most likely thing is that it's none. In my example on the board, I've got 3. Wait, why are people saying we've got 1? Oh, they just want to talk about one equation. This is, yeah, so my system of equations has got something going on, right? I see that they're now, I see, Glass Chains and Chats are actually talking about having one equation, and they want to talk about dimensions, so I'm going to back up slightly. My plan was to talk about a system of equations and say, aha, do matrix row operations on it to get it into a kind of state like this. And count how many 0 rows you get. So here we're trying to solve after row operations. After row operations, we end up with this, and then look very carefully at the kind of 0 rows. But I see now that they're actually asking about dimension of the equations. So I think this is a job for Desmos 3D, isn't it? Oh, I've accidentally loaded my trousers. No, I have not loaded my trousers. That won't make any sense to new subscribers. Right. Don't ask about the trousers. Okay, so in chat we've been given the equation 3x minus 2y plus z equals 0. Again, Desmos getting too excited. I haven't finished typing yet. And that gives us a sort of entire plane. Desmos is showing us loads and loads of points that all satisfy that equation. And I suppose the surprising thing is that it's two-dimensional. When I was in school, they told me something that was pretty much just, well, you started off with 3D space, and then you put a constraint on it, and now you have 2D space, because you have been constrained. I didn't find this very convincing at the time. I suppose these days I would think of this as saying you can find 2 different vectors in 3D space that both satisfy this equation. And the reason you can find 2 it's rank nullity, isn't it? It's just rank nullity. I mean, the fun thing is that things like this are also 2-dimensional planes, right? You don't need all 3. You don't need all 3 letters of the alphabet to be present there. Even if you've only got 1 or 2, then you still get a plane. And there's some special cases in there, perhaps. Okay, so class change is talking about the rank of the matrix. This is just rank nullity, right? Okay, you're talking about rank of matrix. Do you know something called rank nullity? It's this relationship between the rank of linear map. Do you know rank nullity? Okay, because the thing you've just told me reminds me of rank nullity, because the punchline is something like the rank of this matrix is 2, the dimension of the things where it's equal to 0 is 1, you have a line. So I think someone in there might be, the thing they're not saying out loud in between those facts might be 2 plus 1 is 3. I wonder if that's what they're trying to teach you. Sorry. Partly this is trying to work out what stage or what kind of context we're at, right? I think this is a rank nullity thing at the moment. Yes. Yeah, and we're really testing how much linear algebra I can remember. Let's see if I can do it. Yeah, class change, you're going to teach me something quickly, because I'm going to try and remember rank nullity. In the kind of like sense that, okay, so you've got a linear map. Can I remember this? I can't remember the definition of rank. That's a bit embarrassing, isn't it? You've got a linear map that sends things to matrix times x, and then nullity measures something like the set of x such that ax is 0, and it's something like the dimension of that set. So there's lots of vectors that might get sent to 0, and the dimension of that vector space, is it a vector space? Yeah, of course it is. The dimension of that vector space is called nullity, I think. Oh, and rank is the number of linearly independent rows or columns inside a matrix. Which is something like the number of equations you're given, sort of, if they're different from each other. Not my example higher up the page. But if you're just given, maybe here's a missing piece or something. No, we already have the best viewers. How many times do I have to say this? How many times? We already have excellent viewers. I really don't know what they want me to do, except anyway. It'd be good if I could opt out of that, right? I could say I've already bought the thing, right? I've already got great viewers. I bought it already. No money has changed hands. Okay, so I'm not feeling that I can write down a similar sort of thing here. Rank is something like independent rows. Missing ingredient, I was about to say. It was a callback. It was a callback. It was a callback to Herb buying a car or something. It was a very funny joke. Missing ingredient, third time lucky. Something like, if you give me an equation, x plus 2y plus 3z equals, or not even equals 0 yet, but if you just give me an equation, that's not a linear map on its own, because it doesn't map R3 to R3. This sends R3 to R, and in order to make this into a map from R3 to R3, we can maybe stick some zeros on it as well. Maybe that's the missing ingredient, because now this is a linear map from R3 to R3. Give me 3 numbers x, y, and z. I give you 3 numbers back again. 2 of them are 0. Where now maybe we can talk about the rank of this linear map. I mean, it was, no, sorry, my language has gone a bit wrong there. It was a linear map before. It just wasn't a matrix. I don't think you should ask me this. It was a linear map before. It was a matrix before. I should try to fix things. 4x plus 7y minus pi z, 0. We write this as a matrix. We see that both rows, all columns are linearly independent. There's 2. The dimension of the solution is 1. Class change. That makes sense to me. Yes, I'd buy that. It also makes sense with my stupid intuition that you start with 3D space and you apply 2 restrictions and you end up with a line. I think I'd buy that. Yeah. Crucially, you've checked that both the rows are linearly independent. Oh, so the rank is 2. I'm not improving the rank by sticking these zeros in, am I? This is a stupid idea because it doesn't affect the rank. And you're perfectly happy to calculate the rank on a, well, what that looks like a 2x3 matrix or something. Yeah, okay. Brain fart on my part. You can calculate the rank even without sticking extra zeros in. And although I took 3 attempts at telling you this extra ingredient, it was not a good ingredient. It's a stupid ingredient. Cool. Square matrices. So in my brain I was only thinking about square matrices. At one point I said matrix to mean square matrix. As soon as you said rows, I was thinking square matrix. I told you off for mapping R3 to R rather than R3. Cool, right, I've learned a lot about myself and my memory of linear algebra from university. Charlie wants to know about stats, which is even less likely that I can say anything intelligent about stats. Let's go. Where are we going? We've got a little to-do list. It's going well. We're going to have a quick look at prelim. Can we have a quick look at prelim stats? RFL. We sort of got to where we wanted, right? We sort of got there. I don't think I helped, but thank you for finding this maths stream on Twitch. The mug today. This glass has got some beer festival stuff on. It is from the Cambridge Beer Festival when they were back in person doing an in-person beer festival. It's a little welcome back fact. Their glasses always have this slightly unsettling artwork of beer kegs but with faces. But they've been doing it for so long that it's kind of become cute, even though when you first see them, horrific. Most of the glasses in my house are from beer festivals. Not even through, that sounds really problematic, doesn't it? That sounds really terrible. Not even that many beer festivals, just, it's not that many glasses. I was trying to load up stats so I could put stats on the screen and say this is not so bad. My attempts to load up stats, there we go. So I'm not sure people know this, but also puts their lecture notes for maths just online. Yeah, this is not it's not a drinking stream. Is that allowed? I reckon that's probably not allowed. Drinking streams. I'm not putting this on screen because this looks like notes. We have notes on screen already. What am I doing? Something I remember is the phrase maximum likelihood estimator, which I'd not seen at school. Or maybe I had, but I hadn't been called that or something. I was trying to estimate what the parameters were behind some observations. That's a good phrase. I think we saw the tank problem. Numberphile just did a video about the tank problem. So maybe I should just tell you to look at the Numberphile video from a couple of weeks ago on the tank problem and to think about the stats in there, because that's got a kind of likelihood estimation thing to it. You don't know how many tanks. The problem is you don't know how many tanks there are. So there's a parameter you don't know for how many there are. They're all numbered, and you observe some tanks selected from the collection, and you need to estimate from the ones you've seen how many there are in the world. And that's a problem to work out what the most likely number is for the parameter of how many there are. Obviously, the number that there are affects what you see in a slightly complicated way. If there's 1 million, then you'll see things about 500,000, right? So do you just take do you do something like just take the average of the ones that you've seen and, I don't know, double it? Maybe. Can you do better than that? Is that even good? I think it was the stats course at university that gave me tools and techniques to actually think about those problems that I hadn't been able to think about before. Yeah. Wait, why are people talking about maths and stats in chat? People are talking about maths and stats in chat. Shall I do the Oxford version? The Oxford version is that you apply for maths and stats, and then after first year, I'm going to scroll my stupid idea off the board. You apply to do maths and stats. That's the only thing on UCAS. G100. This is Oxford. And then after first year, I think after fourth term, during second year, you either switch to doing maths or maths and stats. I say switch. Maths or maths and stats, and then you continue onwards, get a degree in maths or in maths and stats. The maths and stats comes with some sort of bonuses where you get extra stats options, but also the kind of that side of the tech tree has this kind of restriction. Some stats options are now required. If you stay on the math side, you still get some stats options, but they're optional. I mean, tautological, isn't it, to say that options are optional, but you do have to say. And this gives you a kind of maths and stats diagram where you start off on one side, and then you go over here. At Oxford, there's a kind of three-year, 4-year version about whether you stay for the third year or the fourth year, for a master's or for a BA, but you make that decision later on as well. It involves more options along the way as well, which gives you this kind of trouser-shaped picture for how maths and stats works at Oxford, containing sub-trousers for the further choices. So that's good. Well, anyway, I've been not keeping up with chat. Can we talk about ants? I'm going to talk about ants. Do we have some of the option stuff? Not really. Mostly during the summer, a lot of the academics get some research done. There's a little bit of summer school activity, but not as much as like the UMT does, not as much as some American universities do. So there's probably other fun stuff going on in other places. Yeah, Oxford's doing a couple of summer schools, but quite focused. Right. Not putting more trousers in Desmos. And someone said they're cooked, but I don't think they are. Top school for maths. Oh, they're talking about university choices because they missed their firm offer. Very, very sad. I think you're fine because on the trouser diagram, this is a little bit hard to put on the trouser diagram, but we've got a kind of, even at Oxford, and lots of other universities do this as well, there's a kind of, not quite fourth year, but kind of masters, standalone masters, which is over here being its kind of own trousers. And the reason that the trousers picture is inaccurate is that, in fact, lots of these trouser legs join up again later on, and lots of people end up in the same sorts of places. So after doing any of these things, there's lots of kind of crossover for where people end up next, for whether that's further study. Now that I'm labelling them, I have to do all of them, don't I? Just to be really like further study, world of work. Research is probably something that people are thinking about, and actually people's careers are much more complicated than just going down one side of the trousers or the other. And the reason that trouser diagrams are a little bit misleading is they make every choice feel like kind of branching of the universe rather than a continual stirring and mixing. Yeah, so then if the trousers reconnect, that's when you get into the interesting topology stuff, right? Because once you've got trousers that once you join the legs back together again, so you have trousers where the legs join back together, then that's how you construct something with interesting genus. So if you stick these together and stick these together, then you end up with one of these. So that's where the party really starts. When you get up to that kind of higher genus thing by joining the legs back together. So yeah, keep an eye out for that later on. Right, trigger warning for life outside of education. Right, sorry. The concept of doing something outside of a university setting or whatever. What are we doing? Can we do the ants problem? We're going to do the ants problem. Watch loads of change entries secretly applied to Cambridge and not a very well kept secret, and also fine. I did the same thing in that I saw a lot of James Outreach before anybody else. That's a stupid way of describing writing a personal statement. I wrote my personal statement before everybody else, but then I still applied to Cambridge. Right. All of the topology pictures are green is one of my favourite memes, because for me it only exists in meme space. I don't think I've seen a green torus outside of memes, but which kind of undermines the meme, but never mind. All of the stuff about dogs chasing each other reminded me of a problem that I like, so I'm now going to do that on the stream, just because we've got 10 minutes. And if I keep talking about A-levels and stuff, it's just going to make everyone very, very nervous, because it's A-level results day in the UK quite soon. The problem is like this. You have the unit interval 0 up to 1, and you have 100 ants. The fun bit of this is going to be drawing the ants. 100 ants who are on the balance beam. Ooh, balance beam like the Olympics. Wait, is it too late to rephrase this as an Olympics thing? Yes. Don't get ants at the Olympics. Okay, either going left or going right at speed 1. Like the dogs move at speed 1 when they're chasing each other. If two ants meet, they bounce off each other. So let's try and draw that situation. And this one's going right. Then they start walking in opposite directions. Afterwards. How long until what's the maximum amount of time or something? The problem is that this question takes so long to state and then so little time to solve that most of this is me talking. No, not how long. What's the maximum amount of time? What's the maximum amount of time? What's the maximum amount of time before each ant, oh my goodness, each ant has either reached 0 or 1. So when the ants reach 0 or 1, they fall off the end. It's a good solution, yeah. It's a good solution because the question takes so long to state, and it does feel like it's difficult, because you can imagine a case where this ant takes a really long time to leave the balance beam, because over time it could go left and then meet an ant, change direction and go right, then meet an ant and go left. And I guess if these ants start very, very far away, so there's like 49 of them over here, 50 of them over here or something, I might want those the other way around, then it can get all the way to, it'll only meet this one when it gets about a quarter of the way in. And then it'll bounce and it'll go, I guess it'll get back to the halfway line, having wasted time walking to the quarter mark back to the halfway point just in time for this ant to get here. I guess it bounces off just the front one, so I'll have them all slightly spaced out. And then some sort of complicated thing where it's going to come back again as the next one of these ants starts approaching. And then it's going to do some sort of complicated geometric series thing in here. And then finally bounce off and go to over there. That's kind of not clear. Ah, there is now a picture on Discord. A picture of this problem. Because now we're discussing it. We talked about this on Discord a little bit and said no spoilers, but I guess we'll try and no. No, I can't see it. Or is it in non-maths? Oh, it's a picture of your green Taurus. There's a green Taurus. I won't show it on the stream, but it's in Discord. It's green. And toroidal. Cool, phew, I thought you were posting a picture of the ant problem. I reckon I've got another 5 minutes of content on the ant problem. Who wants to tell me in chat, instead of doing this geometric series, for this ant bouncing off to approaching armies with the ant going bounce, bounce, bounce. Instead of doing that geometric series, what should I do instead? You can tell me in chat. We'll do spoilers now. And while you're typing, I'm going to start doing this geometric series. I'm imagining that I've got 49 ants over here, 50 ants over here. And it's going to do lots of bounces where after it's bounced off the first one, the remaining army of 48 keeps marching onwards. That's at this point here. So the geometric series goes something like, you only have to walk back half? No. What's the rule here? You walk halfway towards where the approaching army, and you turn and you walk. But this one's been going already. Yeah, that's a good answer. That's a good answer. The ants are a bit sad that you don't think they're individuals, but they do take your point that after the bounce, the dynamics are exactly the same as if the rule was they just walk straight through each other. I'm still going to draw the same picture, aren't I? This rule of bouncing is the same as if they're just passing through each other. This one approaching from the left, you could say that instead of bouncing off, you could say that it's just passed through. And the difficult thing that's happening with the bouncing is just a change of identity, which Maths 2 slightly rudely does not believe in identity, France, but yeah, if they don't have identities, then they can just, you could switch this behaviour to say, well, I just have them passing right through each other, which is pretty good. Thanks for the, oh, is that a tea time? I didn't know you could do that. Oh, tea time again. Right, good, we're going to wrap up the stream. Wrap up the stream in a minute, I think. Have tea again. Twice in one stream. Didn't know that was possible. Need to change the settings. No, I don't. Good. So the ants pass through each other. The final answer is something like the ant at the back of this army is going to keep marching. And even though the rules say it's supposed to bounce, I'm going to imagine it just walking through the other ants, and it will definitely get to 1 at some point within time 1. So after time 1, all of the ants will end up at either 0, having reached either 0 or 1. Is that convincing? I think I'm supposed to argue backwards or something, really. It's clear that I can choose an ant that gets to 1 in time 1, but really I think I'm supposed to argue something about consider any potential ant that has stayed inside for more than time 1. Well, all of its interactions are the same as, instead of bouncing interactions, that's the same as passing through interactions. If you track back, that really this ant, a different way of reading it is that it came from over here. And there's a limit to how far right it could have been when it started. It's a little bit more subtle than I thought. Is there an optical illusion for this? Good. So short, so good. Right. I'm going to call it there, I think. We had a good Trousers of Destiny moment. We did do the ants. Somebody came in to ask a maths question and I made a mess of it. I did a terrible job of that, chat. But you win some, you lose some. Yeah, we had a big calculation. Forgot about that. I think if we do dogs again, I might focus on just making pretty pictures because I liked that. The pretty pictures. Oh yeah, and a correction. Thank you for reminding me. Correction. Ages ago, there was an argument on the stream where I was wrong. There was a mug with a hole through. And I was wrong about the genus of this thing. If you punch a hole through a mug, I claimed that I gave it genus 2. I'm wrong, I gave it genus 3. The thing I'd not allowed for was handles aren't hollow. This is a correction for something ages ago that Maths222's reminded me about in chat. There's a mug with a hole punched through it, which is relevant because it's a thing that Matt Parker is selling. Like Maths Gear. Maths Gear is selling a couple of these things. And I've been confused about the genus. So I have this utilities puzzle mug, which is pretty cool. And has genus 1, because it's a donut that you can drink coffee out of. But they also have a higher genus one, where I think we tried to do this problem on stream. And I said this had genus 2 because I was imagining the punch through to be like another handle on the inside, but it's not another handle, it's hollow. Handles aren't hollow. And that gives us an extra genus. Right. Oh yeah, Herb's got one of these, right? And it's got genus 3. So sorry for, I think I argued for this having genus 2, but it's actually got genus 3. And there you go. Good. Yes. Good, okay. And this one's only got 6. How many has it got? I think it's got, oh yeah, it's got 5 houses on it, which doesn't feel like very many for genus 3. Feels like you could probably get away with more, but I don't really know. We were trying to answer the hard question of what versions of the utilities problem can you solve on genus 2 and genus 3, and I had this big problem that I could not draw genus 2 surfaces, and then by the end of the stream I could not draw genus 1 surfaces either. And I don't know what a genus 3 surface is. I learn a lot doing these streams. You know, if I didn't do this, I would just go around thinking that I knew stuff. It would be very, very bad for me. Yeah, I would just tell people like, yeah, I do know what the rank of a matrix is. Of course I do. And yeah, reckon I know the genus of this object. I know what a handle is. It's only by doing this stream that I get to find out all these things that I don't know. Right. Not sponsored. Yeah, what's going on? Is chat behaving? Chat's behaving. Chat wants a step question reward, which is not a phrase that anybody's used before, Mary. Right. Okay. Imagine if Herb has been a sort of kind of scam bot all along. Imagine. Gosh, I'd prefer it if the scam bots were like this. Yeah, Maths222's put the animation in chat. I'm not sure what I'm supposed to say this. Maths222 showed me this animation. Yay! That's such a cute animation. Genus 3. Is that /J just so that I don't ban her? Right, okay, we're calling it there. Thank you for corrections. Thank you for the learning. Every day's a school day. Right, I'll see you. Oh gosh, am I around next week? I think I'm not around next week. When am I around? I think I'm travelling to yet another summer school. So I think we're having a week off and then see you in 2 weeks. Thanks for the stream. Yes, thank you for the stream. Right, bye. How do I turn it